here we're going to talk about how we get the data, or how we can create data to feed our benchmarks. So I want to start by sharing some key learnings about some data sets that we've created in the past, and also that have influenced the way that we're creating data sets for MLPerf. So we're going to look into some prior work in deep speech, ImageNet, and then talk about our new data set, the people speech. And from there, going to share some learnings about how data fits in overall when we're creating new machine learning solutions, and how systems can actually play a role in helping us create better data sets. So how we've used computers to not just evaluate or run our models, but also help us create our data sets. Okay, so the starting point here, actually the motivation for the people speech was we're trying to put together benchmarks for speech data sets. And we realized that the public data sets were just too small and not representative of what was being used in industry. And just as one case study of what's actually being used in industry, about 5 years ago, I was working on a project that was called Deep Speech at Baidu. And this was a project that was an attempt to bring up a new speech system that was based on deep learning from scratch. And looking back on that project, it's really clear to me that the main thing that improved the quality of that system, the accuracy of the speech recognition system, was the data set that it was trained on. So this plot here is showing as we're adding more data over time. So the x-axis here is time over the initial days of the project, the first about 3 months of the project. And it's showing both the amount of data that's added and the impact on the quality or the accuracy of the system. So there are a lot of technologies that went into deep speech. We had frameworks coming online for the first time. We used deep learning for the first time. There was a lot of specialized deep learning technologies like RNNs, deep residual models, and things like normalization, like batch normalization, that all came online around this time. But the thing that mattered more than any of that, all those things matter. We needed all those pieces, but the thing that impacted the accuracy of the system, or the quality of the system the most, was the data set. So here you can see the impact. So the thing I've realized about deep learning, especially the early days in deep speech, was that deep learning systems depend on data in a way that most systems that I've seen before really didn't. You can build a lot of technology like the network stack or an operating system where you're without any data, but you just cannot build any machine learning solution without high quality training data. So that should be pretty clear. We know these systems depend on data. And if we look back, so we've actually made a lot of progress in a short amount of time in this field. So if we look back towards the early days of deep learning, like models like AlexNet trained on the initial data sets like ImageNet, we've the existing systems at that time we made a lot of progress since then. So in those days we would evaluate models on CPUs, and we'd be using models that were inspired by LayNet, like old ConvNets from the 90s. So the models that we have now are substantially more advanced, and the systems that we use to run those models are substantially more advanced. But we're still using the same data sets. So we moved on from AlexNet, but we're still using ImageNet. Why is that? So one reason is that data sets like ImageNet are open. So it's an important characteristic, and we see this in use of machine learning systems in production, but also in research papers, that the most widely used data sets are open. So it's important to keep in mind when we're creating new data sets that we can create them in a way that's open and that can be leveraged by the entire community. So one important aspect of data sets is that they're open. But the other thing that I think is an important lesson from ImageNet is just how hard it is to create a data set like ImageNet. I think we're still using ImageNet today, because creating something that's bigger and better or different and better is a huge effort. So this figure here tries to explain this in a little bit more detail about what does it actually take to bring up a new machine learning solution. So if I wanted to build a new machine learning product like the recommendation system for Netflix or the Siri personal assistant, how would I actually build a system like that? So these are the three main steps that we've seen repeatedly across these systems. So the first one is you have to actually create a data set. And these systems just do not work without a data set. From there, you can train models, evaluate models on that data set. You can find a good model that performs well on that data set. And then finally, you actually have to take that to production, take that to deployment. And for systems that reach a lot of users, there are a lot of operational aspects of deploying to millions or billions of devices. But I want to emphasize here the technologies that go into these different steps, and especially contrasting the middle area here with so machine learning engineering with data engineering. So in machine learning engineering, we're actually really good. We've made a lot of progress. So we have productive frameworks, we have really good models that usually work off the shelf, and we have systems that are very fast at training them. So recent MLPerf training benchmark submissions have shown, for example, that we can train ResNet 50 on all of ImageNet in 30 seconds on a few thousand accelerators. And so that's highly productive. We can train models really productively. But creating data sets is actually really hard. You notice, we train models all the time. We usually don't create data sets very frequently. So if we look back at the case study of ImageNet, it took ImageNet creators about 5 years to build that data set. And you also note, in the benchmarks that we have, you can frequently train models, open division, you can do whatever you want. You can potentially, train new models, evaluate new models. Actually creating a new data set from scratch is extremely difficult, and it's still, not frequently done. We set out in MLPerf, especially to help us create a speech benchmark, to build a new speech data set. So we spent about 1 year building a new speech data set, and I wanted to share some of the things we learned from doing that here. So one is that it is possible to do this. So we collected about 86,000 hours of public labeled speech in about 1 year. And that's comparable with the data set sizes and quality that's used in production systems. So we're able to kind of get up to speed with production systems in about 1 year. We were able to do this actually with a really interesting observation that I had never seen before. Like, we really dug into this. We saw this about halfway through the project. There's an enormous amount of open, commercially usable licensed data on the internet. So it's especially the emergence of the Creative Commons initiative. So open source initiatives like Creative Commons have created permissive open licenses and have contributors who have tagged their content with those licenses and actually made them available through internet platforms and just directly on the internet that's available through search. There is an enormous amount of data that's available on the internet that has a license that's open and compatible with commercial use. So this was a really important finding that probably actually in multiple fields, not just in speech, there's plenty of open data that's available. So there's plenty of raw materials to create new data sets from. So once we have the raw materials, we actually have to create the data set. The next thing that we learned is that we can use systems to make the process of creating that data set, so converting from the kind of raw, unorganized, unlabeled data that's available on the internet into a high quality labeled training set that's able to train a supervised deep learning system. We can use systems to help. So in speech recognition, it turns out there's a technology that's called forced alignment that essentially uses a weak speech recognition system to match high confidence matches between audio and text that's found on the internet. So sometimes people will caption things that are on the internet. Search engines can find it. The forced alignment system can do the matching. So we can actually avoid a lot of manual labor-intensive work to create a data set like this. So it's far more efficient to use something like forced alignment than it is to use a human labeling pipeline. You can use a human labeling pipeline. We came to the conclusion if we did that, it would cost us about between $1 and $5 million to label this amount of data. Using a forced alignment system, the compute cost is about $2,000. So it's an enormous difference to take advantage of systems to label your data. And then we're able to reuse modeling technology. So we used a TPU cluster to train models in this data set, make sure that we're able to train effective models. We did discover some problems. So we discovered that probably expected, but we discovered that the data that you just pull if you crawl the internet is heavily biased. So the figure on the right here shows the distribution of languages by number of speakers in the world. So you note that English has a lot of speakers, but there are quite a lot of other languages. And if you just cover English, you actually don't cover most of the world population. So your speech system is not usable by most of the population. But when we crawl the internet, we mostly get English audiobooks. So we actually, if we're just crawling, we're not thinking about diversity, we're not covering most of the users of a system like this. And then finally, while we were able to get this done in about 1 year, that's still a long time. So compare the 1 year of creating a data set like this with the amount of time it takes for us to bring up a new model. There's an enormous difference. Many people contributed to this, so this was a big effort, and the whole community kind of came together to put this data set together. So the last thing I want to mention is while we were building this data set, I just wanted to outline the system components that we used to do this. So we're able to take advantage of essentially these technologies that made it more efficient for us to create the data set. So the first part here is the data book. We start from a specification of what we want in the data set. We don't just want raw, unfiltered content coming off the internet. In this case, to build a good speech benchmark, we like coverage of multiple languages and a large vocabulary, so to make sure we can support a general use of a speech system. So we start with the specification, what we want. From there, we go off and search the internet. We explicitly avoid anything that is not Creative Commons licensed. We need to be able to distinguish between content that has a Creative Commons license and just raw, unlicensed or unknown licensed content. We use a search engine to do this. We use search technology to do this. From there, we've gathered a lot of unlabeled data. We use the forced alignment algorithm to label the data. So this produces a large amount of labeled data. And then finally, not all of the data is labeled correctly. So we have to filter it, we have to train models on it, we have to evaluate them. We have to go back and perform consistency checks and quality checks to essentially remove data that's mislabeled or maybe has incorrect metadata or is just corrupted in some way. And then finally, we can export it and we can share it with downstream models and downstream benchmarks. And so this is a process that we use to create the data set. Okay, and that's really it. So main thing to remember from this talk is, data is extremely important. We are really good at building models, but it's still really labor intensive, really expensive to build new data sets. Systems can help here. So we have advanced frameworks that have greatly accelerated the process of building new models, but we really don't have anything for data sets yet. So hopefully these case studies have kind of given you an idea of what, if we did build systems like that in the future, that could make it easier to create data sets, what they could look like. And that's it. If you'd like to contribute, please get in touch with MLCommons and we have a get involved process. If you'd like to learn more about data-centric AI, there's a series of talks that are being created around this.